In this lesson, we are going to learn how to construct and analyze box and whisker plots. Here's a large set of data, and it's hard to make heads or tails of what's going on unless you really study this. So this is why we create graphs to help us better comprehend what we're looking at. So a box and whisker plot takes a huge amount of data, and then we find 5 values, which we call the 5-number summary, to create this nice picture. So the 5 numbers you need to find are the minimum, the lower quartile, also known as quartile 1, the median, you already know how to find that. Occasionally that's called quartile 2, the upper quartile is quartile 3, and then the maximum. I also want to mention that occasionally you will see an outlier, which is a number that is quite far from the other values, and that's indicated with an asterisk. There's an actual formula for computing outliers. For now, we're just going to say it's a really big or really small number compared to the rest of the data. You can find several other things just by looking at a box and whisker plot. One is the interquartile range, which is the middle half of your data. You find the interquartile range, known as the IQR, by doing the third quartile minus the first quartile. That's going to give you this IQR. You can also easily calculate the range by taking your maximum value minus your minimum value. Okay, so let's put this into practice. Here's a list of ages of runners participating in a 5K race. So we are going to find our 5-number summary and quickly make a box and whisker plot. And what you're really going to be doing is finding your medians over and over. Okay, so we're going to go through 2 examples here. This first one has an odd set of data. So I quickly count them: 1, 2, 3, 4, 6, 7, 8, 9. I see 9 numbers. Okay, so I would have an unbalanced set. So what I do is, if I have 9 numbers, that means this upper 4, this will be my upper half, and these lower 4 here are my lower half, and that leaves 43 smack in the middle, so 43 is my median. Okay? The other 2 that are really easy to see are your minimum and your maximum. That's just your least and your greatest value. So my minimum is 33, that's the youngest runner participating in this race, and then we've got somebody who's 68 still running. Quartile 1 and quartile 3 are just the medians again. You're looking just at your lower half. So I'm looking at just these 4 numbers here. And what's the median? Well, it's going to be what's smack in between this 35 and 40. So how do we find that? It would be the mean of those 2. So I can add 35 plus 40 and cut that in half, and that's going to be 37.5. And then the third quartile, or Q3, is the median of the upper half. So that's going to be halfway between these 2 values. So how do I find that? I do 46 plus 50 and then cut that in half. So that's 48. Okay, so what I'm going to do now is I'm going to construct my box and whisker plot from those 5 values. And I am going to number my number line. So my lowest is 33, so I'm going to start with 30. And my highest is 68, so I'm going to count by 5s. 35, here's 40, 45, 50, 55, 60, 65, 70. And that's going to give me high enough to plot my 5 values. So these 5 values I plot are going to kind of hover. So 33, I'm going to put right here. It's 37 and a half. It's about here. 43, 48, and 68. The outer 2 create the whiskers, and these inner 3 put little vertical segments through it to create your box. It's always a good idea to have a title so anybody looking at your plot knows what this is about. And you could be asked different questions then. You could be asked, so what's the interquartile range? So I'm going to write IQR is equal to, you take 48 Q3 minus Q1 minus 37.5 is 10.5. So that means that half my runners here in the center, half of them are within 10.5 years of each other in age. I could also be asked, what's the range of the runners? So I would do 68 minus 33, and that is 55. So 100% of my runners are 55 years, within 55 years of each other, which is a pretty big range. We're going to make one more box and whisker plot. This time I've given you an even set of numbers that are the pounds lost of weight loss participants on a 2-month eating plan. So the first thing that jumps out at me is these numbers are not in order, so quickly reorder them from least to greatest. I crossed them off as I numbered them, and I counted 10 values. So the first thing I'm going to do is split my data into halves. So I'm going to have 5 in each half. So here's my lower half and my upper half. So then I find my median next. So my median is going to be halfway between the 12 and 14, or find the average of the two. Both thought processes will give you 13 for the median. My minimum is 3, somebody lost 3 pounds, and the maximum is somebody lost 21 pounds on this eating plan. Then my quartile. So quartile 1 is the median of the lower half. So the lower half is here, and the median is 7. Median of the upper half, known as quartile 3, is 15. Now I'm going to draw my number line, and I'm going to count by 2s. So I have 2 all the way up to 22, and I'm going to plot my 5-number summary. So 3, 7, 13, 15, and 21. Outer 2 connect to make my whiskers, and the inner 3 put vertical segments through it to create the box. Okay, good thing would be to put a title at the top. Okay, you may also be asked to find things like, what's the range of weight loss? So you take the highest, which is 21 minus 3 is going to be 18. So my range here is 18. My interquartile range, the middle half of my data, is again Q3, which is 15 minus Q1 is 7. So this equals 8. So the middle half of my data here, those people are losing within 8 pounds of each other. Now what happens more often in real life is that the box and whisker plot is already created for you. Or if you have a job where you're dealing with data, technology, we have computers, they're going to make the box and whisker plot for you very quickly and accurately. And more importantly, you have to be able to interpret them. So one of the things that's critical is to understand how box and whisker plot is separating your data. So your median is your midpoint, which cuts it into 2 halves. And then each of your quartiles, you find the medians again, which means that 25% of your data, or 1/4 of your data, is in each part of a box and whisker plot. Okay, so when you see that one whisker is longer than another whisker or a part of the box, it's showing you that your data is more spread out, okay? So here on the left, this one's going to be more spread out than over here on the right. Let's analyze this box and whisker plot showing Algebra 1 test scores. So maybe this is a class of 20 students. That would mean that there are 5 kids on each part of this box and whisker plot if we split it up equally 4 ways. All right, so my first question here is, why is the left whisker longer than the right? Well, this one's going to be longer because the scores here are more spread out. So we got a couple kids over here that did really poorly on this test. Somebody got like a 27% right here. But maybe there are 27%, a 42%, 55. They're more spread out. Whereas over here in this right one, their scores are closer together. So let's take a look at our next question. What percent of the kids scored higher than 75% on their test? So I just always like to go, all right, you know what? I know there's 25% in every part. So I'm going to fill this in, and now I'm going to answer that question. So what percent of the kids scored higher than 75? Where's 75? It's right here. So that's 50%, or half your class scored better. Common mistake is kids would say 25% there because they do 100 minus 75. What fraction of learners scored higher than 62? So where's 62? It's about right here. So that is 75%, or 3 out of the 4 parts as a fraction. What is the range of the scores? Okay, so my range is my maximum. So somebody could ace this. They got 100 minus, and I'm doing a little bit of guessing here. I'm thinking that's 27. So I actually have to make that one number. And that means the range is 73%. And then what is the interquartile range? So that is Q3 minus Q1, which would be 85 minus, I think we said that was 62, or 23%. That concludes our short video on constructing and analyzing box and whisker plots. Please reach out if you have any questions.